Yo, what's good guys? Patrick here, welcome back. And in this video, we got to find the domain of a few more functions. So we got these 5 functions here. And notice that all 5 of these functions contain ln within them. So before getting into them, I actually want to do a quick review of y equals ln x, because a lot of the properties we're going to be using to find these domains. So if you remember y equals ln x, the domain for this parent function is just x is greater than 0. Because the graph, if you remember the graph, it looks like this. There's that vertical asymptote at an x value of 0. So notice all the x values have to be greater than 0. Not greater than or equal to 0, just greater than 0. So you can't take ln of 0 and you can't take ln of a negative number. If you try that in your calculator, you'd get undefined answers. Now, we can generalize this property even more. What if we have ln of some kind of expression in general? Because notice with these functions here, we're not just going to be dealing with ln x, we're going to have ln of something a little bit more complex in the brackets. So whenever you have ln of some kind of expression, basically that expression always has to be greater than 0. Right? So same thing here, we just generalized it a little bit more. And this property here, we're going to be using to find these domains. Another thing I want to review is, if you remember from logarithmic equations, whenever we have ln of, let's just put an a here, and it's equal to b. Now this a and this b here, they could be variables. They could also be full expressions, just kind of keeping it general as a and b. If you want to isolate for this a, what we can do is we could write a equals e to the power of b. Okay, so both of these things are the same. So for example, if I have ln of x equals 5 and I want to know what that x value is, right? This is an equation here. Well, x would just equal e to the 5. Notice we use this property where this a value is this x, and then this b value is this 5, and then this format is this right here. So you would either leave that value of x as an exact value, e to the power 5, or you could put that in your calculator, get some kind of decimal. And this actually holds for inequalities as well. So for example, if I have ln a is greater than b, it means that a is going to be greater than e to the power of b. Or if I have ln of a is less than b, then that means a is going to be less than e to the power of b. So this property here, it doesn't just work for equations, it also works for inequalities. And there's a couple of functions here where we're going to have to use this property. So just wanted to give a heads up. Okay, so let's get into these functions. So the first one, we got ln of x squared minus 9 over here. So we got ln of an expression. So that expression, we got to find out when is it greater than 0. Not greater than or equal to 0, just greater than 0. So we got to figure out when is this quadratic greater than 0. Notice this is just a quadratic here. So the way I like to do it is I like to find the intercepts. So notice we could factor this, x minus 3, x plus 3. We have to find out when is that greater than 0, and then I like to graph it. So if I make a quick graph of this, notice the intercepts are going to be -3, +3, and it's a quadratic that opens up because that a value is positive. It's a +1 in front, meaning it's going to open up like that. The intercepts are at -3 and +3. So when is this quadratic going to be greater than 0? Meaning, when are the y values going to be greater than 0? When is it going to be above the x-axis? Well, notice it's going to be here and also here. Now, just a heads up, this is not the graph for this over here. Okay, this is just the graph for the expression inside the bracket, right? So this quadratic is going to be greater than 0 when x is less than -3 and when x is greater than 3. And so that's going to be the domain for f of x. So if we rewrite that in a nicer format, we'll have the domain. X can be anything as long as x is less than -3 or x is greater than +3. And if we were to do it in a different notation, we'd have x as an element from -infinity to -3. Notice it's a circle bracket there because it's not inclusive of that -3. Or it could be from +3 to +infinity. Right? So either way, whichever way you express the domain, that's the domain for this first function. Now what about number 2? We got f of x equals ln of 15 plus 2x minus x squared. So just like we did up here, we got to figure out when is this expression going to be greater than 0. And again, notice how we're working with a quadratic here. So if I rearrange it, got negative x squared plus 2x plus 15. So I'm actually just going to graph this quadratic. So a couple of ways you could do it. I'm going to find the intercept. So I'm going to factor out a negative first. So I'll have x squared minus 2x minus 15. Notice all the signs change. And then I could factor this into x minus 5, x plus 3. Like that. And so if I graph this now, notice that we have an intercept at 5, positive 5 for this bracket, and then -3 for this bracket. And notice that this quadratic, it opens down because that a value is negative. There's a -1 right there. So if those are the intercepts, it's a quadratic that opens down. It's going to look something like this. Okay, not necessarily to scale, but really the most important part, if you get something like this, if you get ln of a quadratic, is just knowing whether the quadratic is opening up or down and where the intercepts are. Because the domain of something like this, ln of a quadratic, is always going to depend on those two things, where the intercepts are and whether that quadratic is opening up or down. So now, when is this quadratic greater than 0? When is it above the x-axis? Well, notice that's happening in this area right here. So when x is between -3 and 5. Right? And you don't want to include -3 and 5, so you don't want to write greater than or equal to -3, because if x is -3, if it equaled that, then it would make this 0, but we can't ln 0. If you remember, as I mentioned in the beginning of the video. And so that there is the domain for this function. So if we rewrite this in a nicer format, we'll have the domain, XCR, x has to be between -3 and +5. And this is x is an element, if we write in this format, between -3 and +5, like that, and then the circle brackets because it's not inclusive of those n values. Moving on to the third function, we got f of x equals ln of ln x here. So notice we have two lns within the same function, but same thing applies if we have ln of some kind of expression. So we got to find out when does that expression, when is it greater than 0? And as I mentioned, that property at the beginning of the video, whenever we have ln of x is greater than something, well, we can just rewrite that as x being greater than e to the power of b. Both of these are the exact same thing. And so if we isolate for this x here using this property, ln of x is greater than 0, it means x has to be greater than e to the power of 0. which means x has to be greater than e to the power 0. Anything to the power 0, it's just 1. Okay, so that is the domain for this function. And that makes sense because if ln is 1, or if x is 1, then ln of 1 is going to be 0 here inside the bracket, but you can't take ln of 0. Or if x is 0.5, for example, we'll have ln of 0.5, which would be a negative number. Can't take ln of a negative number. Right, so the x has to be greater than 1 for this function. So if we rewrite this in a proper format, we could just say x is greater than 1, or we could say x is an element from 1 to positive infinity, like that. Right, so that's the domain for function 3. Now function 4, notice we have 3 lns. We have ln of ln x. And so with this, same thing, we're taking ln of some kind of expression. So what we would do is we would figure out when is that expression greater than 0, right? The expression is inside this bracket here. And what we do is we keep applying that law that I brought in before. So whenever we have ln, now before it was ln of x has to be greater than 0. Now we have ln of x has to be greater than 0. So if we have ln of an expression and that has to be greater than 0, well, same thing. It means that expression has to be greater than e to the power of 0. And just actually to keep it more general, if this is just b, this would be e to the power of b. So applying this, so the expression that we're looking at is the ln x inside the bracket. So applying this basically means that expression inside the bracket, ln x, has to be greater than e to the power of 0. Right? Went from here to here. Use that tool up there. So simplifying this, it means ln of x has to be greater than 1. Right? E to the power 0 is just 1. And now notice we have to apply that rule again, where we have ln of x is greater than some kind of constant. It means x is greater than e to the power of that constant. And e to the power 1 is just e. So x has to be greater than e, which is like 2.7, bunch of decimals. But to keep it nice, let's keep it as an exact value. So this is the domain for this whole function right here. So you want to keep applying that rule, that inequality rule, until you get x by itself, until you get x isolated. So up here, x had to be greater than 1. This one's more restrictive. X has to be greater than that value e. So putting this in a nicer format, xer, x has to be greater than e, or x has to be an element from e to positive infinity, like that. So that's the domain for the 4th function. And then finally the 5th function, we got ln of 5 minus the square root of x plus 1. So like before, that whole expression, 5 minus root x plus 1, that has to be greater than 0. But also notice there's an additional restriction. We got the square root of x plus 1. And whenever you have the square root of some kind of expression, it basically means that expression has to be greater than or equal to 0. Unless it's in a denominator, then it has to be just greater than 0. But notice this is not in a denominator. Right? So not only do we got to figure out this restriction, we also have to take into account that x plus 1 has to be greater than or equal to 0, because we got this square root. So that whole expression under the square root, we got to figure out when is it greater than or equal to 0. So let's actually start with this one. I feel like it's easier. So over here, x has to be greater than or equal to -1. Okay, so that's a restriction on x for sure. So if x was less than -1, let's say -2, if we plug in -2 for this x value, notice we'll have the square root of a negative number. So we can't do that. So that's one restriction on x. Let's figure out what the restriction here is. So what I'm going to do is I'm going to bring this negative root x plus 1 to the other side. So we'll have 5 is greater than root x plus 1, like that. We want to isolate for that x. So what we want to do, get rid of that square root. So we could square this side, square this side. So we'll have x plus 1 has to be less than 25. Bring the 1 over. It means x has to be less than 24. Okay, so x has to be greater than or equal to negative 1, but it has to be less than 24. And so notice we could combine those. If we combine those restrictions, we'll have domain XER. X has to be greater than or equal to negative 1, but it has to be less than 24. And putting it in this notation, x is an element, sorry, this would be a square bracket because it's inclusive of the negative 1, but it is not inclusive of the 24. So that would be a circle bracket like that. Right, and you could test it. So let's say we picked an x value greater than 24. So let's say we put in 25 here. Well, we would have 25 plus 1, which would be 26. But notice the square root of 26 is going to be greater than 5. It's going to be some kind of decimal number, but it's going to be greater than 5 for sure. So we're going to have 5 minus a number greater than 5, which would give us a negative number in this bracket, can't ln a negative. What if we pick 24? Notice x can't be 24 either. If we plug in 24 here, we'll have 24 plus 1, which is 25. Square root of 25 is 5. We'll have 5 minus 5, which is 0. Can't ln 0. Right? So 24 wouldn't work either. Right? So we could be pretty confident that that is the correct domain for that function.